Now that we've discussed some strategies for addition, let's talk a little bit about estimation. When we estimate, the real thing we want to ask ourselves is about. In cases where an exact answer isn't needed, we need to check the reasonableness obtained through the calculation. Estimation requires good mental arithmetic skills and an understanding of the place value in the base 10 system. So, when are situations where estimates are needed and not exact numbers? You need to think about that. And before we examine the methods of estimation, we need to understand that estimates don't represent exact amounts, but they're approximations, and there are certain times in which we'd use them, such as in science. We would estimate a dinosaur bone is 65 million years old. The number of hungry children in the United States is 16 million. The area of the Sahara Desert is 3,320,000 square miles. Jane lives 55 miles from the nearest airport. These are situations in which the exact value is either unknown, because we're predicting numbers that are too large or too difficult to determine, or the value is not a constant. For example, the population and the starving children, or the children that are hungry in the United States. It fluctuates. And there's estimates when the limitations are of measurement. For the difference between measuring the length of a desk or the area of a pond. A word often used when estimating is rounding. If we say it took Jackie 10 hours to get from Boston to Buffalo, that's an estimate. It wouldn't take exactly 10 hours. There are so many variables that go along with traveling. We say Anna gets 34 miles per gallon with her new car. We're saying it's about 34 miles per gallon. It's not going to be 35 miles per gallon each time, based on whether she's highway driving, whether she's city driving, what the pressure in her tires, and so on. Rosie put 2,100 miles on her car last month. It's the odds that it's going to be an exact number of 2,100 miles would be rare. Fred paid $18,000 for his car. Why do we round? Really, it's because it makes comprehension easier. The school budget for the 34,168 students was $153,167,458. Or would we say the school budget for 34,000 students was $153 million. Which of these statements would we rather read? Clearly the second one. Rounding makes computation easier as well. So I'm going to give you a scenario where you're trying to determine the cost of buying new textbooks for your 5th grade class. There are 23 students, and the textbooks are $19.75 each. If you want to get a sense of the cost, you would probably round the $19.75 to 20 and multiply 23 by 20 for the 23 students. We don't estimate the same way in all situations either. The method we use to estimate depends partially on how close the estimate needs to be to the actual number, and whether we deliberately want to overestimate or underestimate. There's also personal preference as well. So let's think about this problem. We have 3 games at Tiger Stadium. in attendance for Game 1 were 75,145. Game 2, 34,135, and Game 3, 55,124. So again, in bold we have the word approximately. We can use the leading digit strategy. We can look at this and say, we have 70,000 plus 30,000, that's 100,000 plus 50,000. We'd have about 150,000. This would be a rough estimate. This, of course, would be an underestimate because we're going about 5,000 under, 4,000 under, and 5,000 under with each of the three add-ins. We can also round our numbers. If we look the greatest place value in each of these total numbers of attendance, we're in the values of the 10,000s. So 75,145 to the nearest 10,000 would be 80,000. 34,135 to the nearest 10,000 would be 30,000. 55,124 to the nearest 10,000 would be 60,000. Add those together for 170,000. Or we could use compatible numbers. Remember, compatible numbers, we're looking for numbers that work with 5s or 10s. So our 75,145, we have our leading digits of 75. 34,135 is relatively close to 35, so we would use that 5 in the thousands to make it compatible and easier to work with. And we have 55 in our 55,124. Add those together, our leading digits would be 165 for our 165,000s. Here's another example. What was the approximate attendance for 3 baseball games at Wrigley Field in Chicago? Again, we have 32,425, 31,456, 34,234. We could cluster. Because they're relatively close together in this case, a very quick rough estimate would be 30,000 times 3, so we'd have approximately 90,000. We can refine that a bit, and we can add our 1,000s. So we have our two 1,000s, 1,000 and 4,000 added together to give us a more refined estimate of 98,000, which would obviously be closer to the actual. Most textbooks offer the following guideline for rounding. If the appropriate digit is less than 5, you round down, otherwise round up. I don't personally like the terms round down or round up. You would stay at the value of the digit if it were less than 5. If it were 5 or greater, you would go up to the next digit. For example, if we estimate 35 plus 57, 35, our greatest place value is the tens, so we would look at our ones. We have a 5 in the ones. That would tell us to round up to the next 10, which would be 40. Because 35 falls between 3 tens and 4 tens. 57 falls between 5 tens and 6 tens. Our ones digit is a 7, which is greater than 5, so we would round to 60. So our rounded estimate would equal 100 because it's 40 plus 60. This would, of course, be an overestimate because we rounded to higher for both of our add-ins. So if the digit to the left of the 5 is odd, we would round up. If the digit to the left of the 5 is even, we would round down. That's a more refined guideline for rounding. So here we have a couple examples of estimating by making compatible numbers. if we looked at these, we can say, okay, our 38 is about 40, our 65 is about 60, so those together would be about 100. 72 is about 70, 27 is about 30, so together those would be about 100. So we have two groups of 100, and then we have the 89 all by itself. So we would have about 289 to add these 5 sums. And here we can use compatible numbers. How would you go about doing this? Our 177 and our 23 would be about 200. Our 359 and our 162 together would be about 500. So we're at about 700. And our 675 and our 315 would be about 1,000. Again, it's a quick way using compatible numbers, not exact numbers, to get a rough idea of what the total will be. Number sense involves the ability to take numbers apart and put them back together. You need to be fluent among different representations. When we were working with numeration, we were calling different place values by different names. So that ability to be fluent among different representations is important. And you need to be able to recognize when one representation is more useful than another, and perform mental computation and estimation in a flexible way. You also need to determine whether an answer is reasonable. So when we're adding, we need to explain why it must be true, or find a counterexample to demonstrate that it's not true. So, if I'm thinking of 3 numbers greater than 70, you know all 3 numbers are greater than 20. If 2 of the numbers are less than 20, the other must be greater than 20. Look at this problem quickly. Is this answer reasonable? Think about it without doing any computations. We have 6,563 plus 4,448 plus 7,203. Would the answer of 17,214 be reasonable? Why or why not? If I just take a look at this using the leading digit strategy, 6 plus 4 is 10, plus 7 is 17. So I have 17 thousands right there, but I'm adding another 500 plus 400 plus 200, so this answer is not going to be reasonable. You can see very quickly that the actual answer is going to be greater than 17,214.